Hello, everyone, and welcome to one more webinar with Solarplaza. Today, we are having a webinar leading up to our Solarplaza Summit Floating PV. And this webinar is this webinar talking about staying afloat and ensuring long-term profitability of floating solar PV assets. So we'll have some presentations today from Ciel Terre and also some questions at the end. I would like to, first of all, just give you a little bit of a heads up for the agenda of today. So, as always, an introduction, I'm Manuela. I'm a project manager here at Solarplaza, also managing the organization of this amazing event that we're going to have in 2 weeks. And we'll have a short introduction from my side about Solarplaza. We'll have presentations from Vincent Grumetz from Ciel Terre and also Benjamin Leblanc. They are both colleagues. And we'll have afterwards a Q&A session with questions from your side, and of course, the end of the webinar after that. Well, just a little bit about Solarplaza. If you don't know anything about us yet, well, we are a sharing knowledge and network platform, and it's our business to accelerate the sustainable energy transition. We have been established already since 2004. We are based in Rotterdam in the Netherlands, and we have organized over 180 events worldwide in more than 44 countries so far. And we have a connecting network of over 60,000 solar PV professionals. And we don't only organize events, but we also publish interesting resources, newsletters, and webinars such as this one of today. Not only Solarplaza organizes events, but we also expanded our branches recently, and we have launched other types of businesses, such as the Solarplaza Consultancy, which provides integrated solutions for new market entries and market penetration. So if you have any new business entries and are curious to enter new markets or explore new business opportunities, you can also reach out to us for the Solarplaza Consultancy. Well, and most importantly, this webinar is actually leading up to our Solarplaza Summit Floating PV event. So this event is happening on the 20th of September in Amsterdam in the Netherlands. And we gather 100 attendees and even more, so over 100 attendees. We gather 20 speakers and sometimes also a very interesting lineup of partners and interesting companies that are attending our event. So for this event, we tried to gather a very interesting crowd of floating PV professionals and enthusiasts. And for this one specifically, we're offering a 10% discount for our webinar attendees that are here today. So please take a look at the end of the webinar. You will also receive, after a few days, an email with some updates and also the code to register to the event. And the code is also here. So please use it and register for our conference. You will see a lot of interesting professionals and also the professionals that are here presenting today from Ciel Terre. Well, another important thing from my side is the practical notes for this webinar. If you have any questions, please use the question box that is on your panel and we'll answer them after the presentation. So we'll have the Q&A session. If you have any technical issues, you can also use the same question box. Let us know and our staff will try to help you as soon as we can. And of course, as always, the presentation slides and the full recordings of the webinar will be available after the webinar. Normally within 2 or 3 days, you'll receive an email with all these details. Well, without further ado, I would like to invite our two speakers of today to join on screen. The first one is Vincent Grumetz. I think he's over there. Vincent, if you are there, hello.
Hi, Manuela. Hi.
Yes,
hi, everyone.
Thank you, Vincent. Thank you for joining. And just a short introduction about Vincent. He is Managing Director of the European, Middle East and Africa markets at Ciel Terre, and he has experience as sales in technical industries, and he also started working for AirMed Technology as an export sales manager in 2006, and he joined Prono in 2011 as sales director, and he is now at Ciel Terre managing the growth of the floating solar market, mainly in Europe. Vincent, very nice that you're joining us today.
Thank you very much, Manuela, for this introduction. Yeah.
Of course. So, I would also like to invite Benjamin to join the screen so that I can introduce him. Hi, Benjamin.
Hi. Hi, Manuela. Hi, everybody.
Welcome.
Thank you.
Welcome. So just an introduction about Benjamin. He's R&D Hydrolio Manager at Ciel Terre. So he did a master's degree in mechanics in France. He started his career as dynamic simulation engineer in the automotive industry in 2006. And he joined the energy sector in 2009. And now he is working at Ciel Terre since 2016 as R&D Hydrolio Manager, managing the R&D activities of the company. So Benjamin, welcome as well. So I think we will start the presentations with Vincent, right? So Benjamin will join us later on. So for now, I will give the floor to Vincent. Vincent, take it away.
Okay, thank you, Manuela. So thank you everyone for participating to this webinar. Today we have a very interesting topic to talk about, which is the long-term profitability and reliability of floating farm. It's quite important, you know. We used to say to our customer and to all the people that we are talking about floating solar that making a nice floating farm is important, but to make it work for more than 25 years is even more important. So this will be the topic that we will go through today. Voila, if you can give me. Yeah. So just a short introduction about Ciel Terre. We started back in 2006 in the rooftop and ground mounted photovoltaic project. But in 2011, we had the idea of developing floating solar. The reason why we went into that direction is that it was difficult to find some good spots to make some rooftop and ground mounted project. And there was so many unused lakes and reservoirs that we believe there was something to do with floating solar. And this is how the story started. During 2 years, we developed the technology, and in 2013, we made our first utility scale project in Japan, which was about 1 megawatt capacity. And from this project, the floating solar market grew, and we had many successful projects all over Asia and then all over the world. To come in 2019 with our biggest project at that time, which was a 88 megawatt project in Taiwan. So as you can see, this was a fast growing development of the company, and still we are at the beginning of this market. There is still a lot to do, and what we can see on the market now is that more and more players are entering floating solar, which sounds very exciting for us. So some figures about the company. We have installed more than 250 projects for a total capacity which is connected to the grid of 700 megawatt peak. We are present in more than 30 countries with about 200 employees. And our current pipeline is about 1.2 gigawatts, which will be installed and constructed in a soon future. So due to this experience of 12 years, we have gained a lot of know-how and knowledge about floating solar that we'll be glad to share with you today. So the main question is how to stay afloat for more than 25 years. I would say that there are 3 pillars that we have to take into consideration. The first one will be the site conditions of where you will install your floating farm. Every site is pretty unique. You have some effect like the wind, the UVs, the waves, and so on, which are different on each site. And so you have to handle those conditions in the best way to be sure that your platform or your farm will be reliable for 25 years. On these site conditions, we will have also to develop the right project. When we are talking about project in that presentation, it's not only about floats, but it's also the mooring and the anchoring part of the project. So we will take into consideration the site conditions to set up the specification of the project and to make a project which will withstand all the constraints from the site. And once you have the site conditions and you have the project developed, you have to design your plans in the best way. As I said, each site is different, and so the plant design will vary according to the site condition. Right now, there is not really standards on the market, but because of our experience, we set up our own standards, which are, I would say, pretty high to be sure that the platform will work during 25 years. So this would be the main point that we will go through during the presentation. It's the first one will be how to develop the most reliable project, then how to ensure the durability of the platform, and the third one will be a return of experience from the field, where we will show you how we are monitoring our existing project. So how to develop the most reliable FPV project? The first thing, as I said, is to handle or to manage properly the site condition. So from the site condition, we will determine what will be the waves, what will be the forces which will be applied on the project, on the floats, and so on. And from the site condition, we will define the specification of our project. From those specifications, the project will be designed, and then we will have to test the project to be sure that it will fit with the site. And to do so, we are using two ways of working. The first one will be some simulation that we will do in our lab, and then some computer simulation. But this will be only theory, and you have to check if the theory is also the same when it comes to practice. And so what we will do is that we will make some real life experiments, and we will make some sampling, and we will get some feedbacks from the field to check that our theoretical development is in phase with the real life of the project. So this is a big challenge for us, because we have to anticipate the 25 years lifetime of the platform, and obviously it won't be possible to make a test of 25 years. It will be definitely too long. So we have to make like a quick testing to be sure that it will work over the years. So what kind of factors will we have to handle? The first one will be the fatigue. Then we will have the aging, the mechanical resistance, and the water compatibility that we will take as input in our development. From these inputs, we will have some outputs, which will be the dimensionings of the floats, plus mooring lines, plus anchoring, the choice of the materials that we will use to manufacture the floats, and then how to manufacture the project in the best manner. So I will give the floor to Benjamin, who will go more into details about all of these factors.
Thank you, Vincent. I will take several examples of the inputs Vincent talked about, the inputs that we use to design our product, and to explain the strategy we are using in order to increase the reliability of our assets, your assets. Let's start by fatigue with an example on a given project. Let's say that in one environmental condition, we have 20 meters per second wind speed coming from southwest. In this direction, we have a edge of 300 meters between the bank and the floating platform. So we can calculate the generated waves. Thanks to hydrodynamic simulations, we know the float movements and the associated number of occurrences of this float movement. This is what we call the cycles. These simulations also give us the input for anchoring fatigue calculations. Fine. So we know the solicitation and the plant for this environmental condition. Let's say that we have 10,000 cycles for this example. But what is the strength? To know that, we performed, and we are still performing, some fatigue tests on a very specific bench in our lab that permits to solicit several real floats connected together in real condition. We are able to build the fatigue curve of our float and thus know the strengths with regard to a given environment. For the example I gave earlier, our float can sustain 100 million cycles. We know that for all the wind orientation and speed that will occur to predict the service life of the project and check that the strength is higher than the solicitation at the end. Fine. We calculate something. Is this right? Does it match reality? How can we be sure that there will be no fatigue issue for more than 25 years? Can go to next slide, please. Vincent? Yeah. So thanks. How are we sure that it works? It's because we are correlating the methodology with the real life, with the reality, the field experience. Indeed, at Ciel Terre, we installed a real site pilot under high fatigue condition. When I mean high fatigue condition, it means that the methodology I presented just before is predicting failure in a very short period of time. And we got real failure on this pilot. These failures were analyzed and characterized with crack propagation streaks observed and that you can see on the pictures. It shows that the methodology that will be used on your project is correlated with reality and has a very high level of prediction. As we will design to avoid fatigue issues for more than 25 years, you will have a reliable asset. Can go on next slide, please. Let's continue with aging. As you know, and we said earlier, we cannot ask you to wait 25 years to get our brand new qualified product. We need to accelerate testing. Many methods exist to test for UV, but what is usually not communicated or proven is the acceleration factor and the correlation with reality. We just defined ourselves this acceleration factor, but we did it properly. We first tested with one of the slowest methods, which is called xenotest, but also one of the most representative because it imitates the sun irradiation at midday. We tested for 3.5 years in order to represent 25 years of real outdoor exposure. Then we tried several accelerated methods to choose the one that gives the same failure mode than the xenotest. This accelerated method, correlated with the xenotest, is able to simulate 30 years of exposure in 6 to 18 months of testing. But as we know that the real life is much more complex than modelization and testing, we are building the correlation between testing and reality thanks to our experience. We are regularly sampling our oldest plant in order to see the evolution of the material because of aging. Sampling started 5 years ago on this 10-year-old plant and is continuing. For sure, today there is no impact of aging, but we are building data for correlation on real site, real product, and material. Next slide, please. Reliability comes also with proper testing. Indeed, you can do all the tests you want, even on quite simple mechanical tests. If you are not doing it properly, you will miss some failure modes, and failure can happen on real projects. This is why we invested in a testing lab and why we have our own testing site. The testing site permits to see how products behave in the reality, under extreme anchoring loads, for instance. This is not feasible on site, on real project, because maximum design conditions are by nature a very low probability of occurrence, and thus are difficult to observe. The knowledge we have of real condition of our products, it permitted to design our own lab with specific benches in which we can test static, fatigue, hot and cold condition for floats, module fixing, and anchoring. We are thus able to represent the real failure mode in testing and increase the reliability of our product with its anchoring system. You can go to the next slide. Last topic I wanted to present you is the water compatibility. Having a water compatible product means two things. It means that the water has no or controlled effect on the product and do not degrade its performance a long time. It also means that the product is not polluting water. For the first point, we are qualifying our material and design for water exposure. Material, product, and anchoring design are different with regard to the kind of water of the project, fresh, salty, chemical content, etc. We are thus selecting the right material and design for your specific application. We, for example, do not use the same material and design for the 80 megawatts in salty water environment than for the 600 megawatts of the FPV project in freshwater. It's not the same. For the second topic, we choose materials that are known and tested for water compatibility. But we are also running some water sampling for years on many sites in order to evaluate the impact of the floating solar plant presence on the water content. The analysis of this data permits to show that there is no big algae concentration increase into water due to the FPV presence. The continuous sampling will permit to know the parameter impacting the more on the potential undesirable effect, and thus we will be able to limit it. Next slide, please. I'll let you continue on the raw material, Vincent.
Yeah, thank you, Benjamin. Yeah, so regarding the raw material, the selection and the qualification of the material is quite important because, as Benjamin was saying, there is a question of UV or aging, there is a question of fatigue and so on. So you cannot pick up whatever material you want on the market. So this process is quite important to be sure that you will have a good product on water. So we spent a lot of time on the raw material identification to check the parameters, to make the assessment of the initial performance, where we will check the type of monomer and of monomer that there is inside the plastic. Also, we will use some anti-UV material to be sure that it will withstand the UV all the way long. And at the end, once we have selected the material, there is a question of making a qualification campaign that we will say that we will split in two terms, short term and long term. So the short term will be to make all the initial tests to be sure that the material is good enough. But then we will make also the long-term test, such as the fatigue, so the fatigue test bench and so on, with some new material to be sure that it will work. Since we are present all over the world, there is no compromise that we want to do on the material, and the material has to be the same in every country that we are we are present. To be sure that that it will work 25 years minimum. Yeah. So once the raw material is selected, and then we have to talk about the manufacturing and the production. Something important here is to set up a very well precised quality plan. So if I talk about the floats, for instance, there will be a lot of tests and checks that we will do in terms of dimension, in terms of thickness of the floats, in terms also of tightness, to be sure that each single float which will be sent to the site will be good enough and will be 100% conform to our quality plan. And at the top of that, we will also insist on the tracking of the float, because if, for any reason a failure happen in the future, and for sure we don't want to face any failure, but we have to be able to identify the whole manufacturing process and to check which batch could be impacted by this issue. So the whole manufacturing process is important for the floats, but also for the anchoring, the tracking, and the qualification of the ropes, of all the components of the mooring line will be important to be sure that the tracking is 100% done, and that we can be confident in the product that you are using on your plant. So this would be all the project development. Now a big topic is also how to make the right design of your plans. So we're not talking about designing the project, we are talking about designing the plant. So the way you and we have to do it is, again, to get all the site and project data information. So this is a very critical point, because if there is some errors in the site information, then it will lead to a completely wrong design of the platform. So once we have all the site information, we'll start the conception of the FPV plant. Then you have to handle properly the construction, because so many failures could happen because of the construction. And at the end, you have to take care of how you operate and you maintain the floating platform. So in terms of site and project data analysis, we will require a good bathymetry, so which will enable us to manage the shape of the reservoir. We have also to get the inputs regarding the wind pressure from the site. If there is any site specification or specific things that we have to take into consideration, the soil composition, to be sure that we will be able to anchor the platform properly. One of the important topic for sure would be all the electrical equipment that you would like to use on the platform, and what we call your strategy and requirements in terms of design. If we are talking about central inverter, string inverter, inverter on water, inverter on the banks, and so on. This will be all the inputs that we will need or we will have to consider to make the design of the floating platform. Once we have all the characteristics of the project, we will be able to pick up the right project, so the one which will be suitable for your site. For instance, if the reservoir could be completely empty, we will have to use a flexible floating platform to follow the shape of the bottom of the reservoir. If you have, let's say, a big wave movement on the site, then we will have to use what we call a wave breaker. Or if the wind is very high, then we will have to reduce the size of the island to be sure that we won't go above the project specification. So once we have picked up the project and we know its specification, we have the design rules related to that project. We will use the design rules to make the design. We will run some simulation to lead to a safe and profitable project. So in terms of design rules, this would be some example of rules that we will use during the design phase. So the first one would be to use the building code to calculate the dynamic pressure and the effort combination. This is quite important. It's kind of a standard in the construction market, and we are using that one to get some inputs in terms of wind to calculate the dynamic pressure and then to calculate the effort on the island. The rule number 2 would be to use a CFD and aerodynamic coefficient to calculate the effort. So here the idea is to check the behavior of the island against the wind to be able to calculate the loads which will be applied on the floats and for sure on the mooring line. The rule number 3 will be to calculate the environmental loads, wind, wave, currents, etc., all together to calculate the number of spreader bars that we will have to use on the island. This is a critical point because here the spreader bar will be, let's say, the part which will make the junction between the mooring line and the island. So you have to use the right number of spreader bar and mooring line to be sure that you have a good spreading of the forces all the way, all the side long. Otherwise, if you have a concentration of effort on one spreader bar on one mooring line, then you can have some big issue. The rule number 4 would be to make some, let's say, very simple shape for the floating farm. The simplest the shape will be, the safest the platform will be. Because if you have like what we call a stair shape on your platform, then you have a stress concentration in the corner, which could lead to big issues. So if because of the site shape, we have to go for a corner like that, then we will have to run some computer analysis with a software called ANSYS to be sure that the forces could be acceptable by the float. And this is just some example of rules that we would use, but the list is definitely much longer. One important phase of an FPV project is also the construction. You can have the best floats, the best design and so on, but if you don't make the construction properly, then you can be sure that there will be issue. So the first step here will be to make some testing. And when we say, when we are talking about testing, we talk about soil investigation to be sure that the anchors that we will use for your project will be suitable and will stay into the ground and will be able to hold the forces that we are looking for. So usually there is some theoretical investigation that we can do, but the best way of to be sure that it will work, you have to go on site and make some testing. So this is pretty important. Then the second step will be about the preparation of the construction work. As you can see on the right picture, very quickly there is a big amount of floats that will be shipped to the site, and you have to be well prepared to handle all the logistic aspect of a floating project. So you have to have the storage area which is well defined, which is well prepared. Also for the launching platform of the platform on of the FPV on water, you have to prepare everything in the best manner to be sure that you won't have a very messy project, and at the end it will lead to errors. Then you will start the construction. Something important regarding the construction is about the as-built survey, because when we place when we install the anchors underwater or even on shore, you have to be sure with a very precise tolerance of the position of the anchors, because this position will have an impact on the length of the mooring line. So whatever you do on site, you have to monitor it to get the information, to run the calculation again, to be sure that you are at the right place, and that, and if not, to readjust the design be sure that everything is okay. And the latest phase of the construction will be the commissioning, where you have to make a final checkup of your platform to be sure that nothing was missing, no errors were done during the assembly, and so on, to be sure that you have a platform which is well installed, well assembled, and well encoded. So let's talk about some return of experience from the field. Benjamin?
Yes, thank you, Vincent. The return of experience is really key. We talked about sampling of the raw material in order to see the UV gauging. We talked about having sites with some pilots with fatigue in order to see how it behaves, etc. One other point, so the return on experience is really key to keep the reliability continuous increasing. One other point is we are monitoring our systems in order to measure the real life conditions and how our products evolve facing those sites conditions. It allows us to understand the behavior of the FPV plant and to adjust our design rules for both the product and the plant based on real experience from the field. These studies are goldmine for us and permit to improve our solutions. Thanks to this field monitoring, we can also correlate what we have established during our simulations with the results from the sites, which help us to establish our own standard based on strong and reliable analysis. This is the example of Yokimine site, Yokimine project. This FPV plant was, for instance, hit by 2 typhoons, and as it was monitored, we know the distribution of load among the mooring lines during these events. By the way, there was no impact of these 2 typhoons of the FPV plant itself. Next slide, please, Vincent. So with the equipment installed and the data collected, we were able to link the plant global effective load and the theoretical calculation. All things considered, the outcome of the site monitoring analysis showed that the FPV response matches the theoretical approach, and it therefore corroborates our methodology, our anchoring design methodology, and the design Vincent talked about, the design of the FPV plant. Vincent, I give you back the floor for the conclusion.
Yes, thank you, Benjamin. Yeah, so as a conclusion, what we could say that if you want to get a reliable floating asset, the most critical point would be, first of all, to get all the site information as precise as possible. As I said, if you are mistaken on the site information, then the whole design of the floating farm will be wrong, and you can be sure that at the end there will be some issue. The product itself, we've been through all the parameters that we are taking into consideration for our product development. As you could see, there is a lot of test and research and development done on the product, theoretical R&D, but then also everything which is about production and quality and manufacturing is important. And if you take the site information, the right product, and the combination of both, you make the right design, then you can be sure that you will have a reliable project. And this is how we have done the 250 projects plus that we have installed all over the world. And this is how we will still do it in the next coming years. So thank you very much for your attention, and we'll be pleased to answer your question if you have any.
All right, thank you so much, Vincent and Benjamin, for the super insightful presentation. I think we all learned a lot and we also received quite some questions already. So I wanted to start by asking a bit of a general question, but which I find it very interesting actually. We see that there is still some difficulty for the industry to standardize, right? There is also something you mentioned that makes it also quite hard for testing better. So to start with a more general question, how do you see the next steps now for standardizing more and be able to test better as well?
Do you want to answer that question, Benjamin, or I do it as you want?
Basically, the standardization is the industry is growing, and for sure standardization will come, but will come with time. Basically, I think all major industry have standards, but new industries are building the standard. Building a standard is long because we need to align ourselves with all the stakeholders in an FPV project in order to decide where we put the line between let's say the reliability and potentially the cost and the risks that are taken. It's always a balance that is needed to find, and that the industry needs to find together, and that's why it's long.
Yeah, I understand. I think everybody can understand that and can relate to that as well, right? It's a very it's basically gathering forces and uniting everyone for making these decisions forward. Another interesting question that we received, which I also find quite relevant, it can be quite of a straightforward answer, but I think for a lot of people it's actually not. One of our attendees asked us, when would you recommend floating PV? So only when ground mounted solar is possible, or at all times? This is a very straightforward question, but also very interesting because I think people see the complications and sometimes the challenges as well ahead, and they already associate, well, ground mounted is maybe easier. We know we have the knowledge available already for some time, and floating is still a bit new. So when would you recommend? When would Ciel Terre recommend floating? Always, or in some specific cases?
I would say not always, because there are like some markets that we decided not to go in, like offshore solar. We won't go for it because we know that the challenges are pretty high, and there are many companies who are trying to go into that direction. And we believe there is a big market for it, but it's something that we decided not to go. Where we would recommend floating solar, it's when there is some difficulties to find properties or lands, and we know that in many countries there is unused reservoir which could be suitable for floating solar. Obviously, if there is no environmental subjects to be handled, and usually we are talking about artificial lakes. So this would be the location where we would say that it will make sense. And also, we didn't talk about this into the presentation because it was not the topic. But when you are going for floating solar, you should have the rent of the properties which are more attractive, and you have also some extra production capacity which is done due to the cooling of the modules with water. So at the end, floating solar makes sense in many locations, but obviously if there is some, let's say, major challenges with the environment, we hardly believe that it doesn't make sense. Yeah.
Okay, well, that's very clear. And on that regard, you mentioned, Vincent, that you haven't been exploring offshore floating solar so far, but we got a few questions regarding that. How do you see, for instance, the future of floating solar on salt water? Is there already any insights, for example, from Ciel Terre on the impacts, positive or negative, on marine wildlife, or just in general? How do you see the future of this kind of application?
Offshore FPV on salty water exists. We built almost a 90 megawatt project in Taiwan on the salty water environment with tides, etc. So it's yes, it's a challenge for sure. It's a challenge because of materials, for instance, but we know how to choose the correct materials and design for this kind of environment. After that, offshore is another question. We need to keep in mind that floating solar islands are the largest objects the man is building. Basically, it's really big, and we are making it floating, and we want to have it floating offshore in very harsh environment, etc. So for sure, the technology needs to move and to move to closer to, I would say, offshore industry, like for oil and gas, etc., with more costs. And is it profitable to do this kind of projects? The question is raised. I mean, this is one of the main points. Find the technology will be able to find, but then is it profitable at the end?
Very good. So I think that everyone can take that takeaway for exploring these type of projects, right? Another question that we got, which was very interesting as well, and it happened also more often here in our questions box. Someone in our audience that has been investigating a project, a site for a floating project, and she noticed that this terrain may dry out quite quickly and quite frequently. Do you have any insights on how the design can help in these situations, and what would be preferred for these type of locations?
Yeah, in that kind of situation, you have to get a good bathymetry, so to know the shape of the reservoir at the bottom. And in that case, we would have to use a very flexible solution to be able to follow the shape of the bottom of the reservoir. So this is something that we have already done. In some cases, I have to be very honest, it's not possible, you know, because of the shape or because of the wind and so on. But we have many projects where the platform completely lays on the bottom of the reservoir. So yeah, this is something feasible, yeah.
And Vincent, yes, there is also the point of anchoring that needs to be taken into account in order to be sure to still anchor the island when your floating solar platform is on the ground. We still need to anchor it.
So
yeah,
obviously it's a higher challenge, but it's something which is feasible from case to case. Yeah.
Yeah. Okay. There, the standardization may help sometime in the future, right?
Maybe,
all right.
yeah.
So I think we have to wrap up soon. Maybe one last question from the audience. We have a lot of them, and also just to let you all know that we will send all the questions to Vincent and Benjamin, and they perhaps can also answer some of them with more time later on. But just to finalize, because we received quite some questions about environmental impact. So have you done any studies on, for instance, the effect of floating solar projects on fish populations or in general water biodiversity?
Yeah, there are some studies which are going on. From what but we don't have, let's say, precise answers to provide yet. What I could say that if we are talking about fish, most of the time when we are on a fish pond, we can just cover a very limited area of the reservoir, you know, to allow the fish to still see the sun and for the oxygen and stuff like that. But from all the information we got from the market and from the people who did some study, there is very limited impact of the floating island on the environment, you know. So we are still confident, and again, you know, if making floating PV would have a significant impact on the environment, it will just not make sense, you know. So we definitely don't want, we definitely will stop it. But from the information we got, it's a very limited impact. Provided some precise information, we are not able to do it yet. Some studies are ongoing, and we'll be able to display them in a soon future.
Yes, just to comment on that, as I said earlier, on the water compatibility, we are making some sampling of water for years on many sites. And basically all this analysis show that there is a very limited impact on the water content, so on the water chemistry, I would say. So if you don't have impact on the water chemistry, you have almost a limited impact also on the fauna and flora into the pond.
All right, perfect. I think that's also a good way to end. Looking ahead, right? Looking at the future for the research and for testing as well. So I would like to thank you, Vincent and Benjamin, for the great presentation and for answering all the questions of today. I would like to end the webinar by also letting everyone know that Ciel Terre will be present at our floating PV summit in 20th of September. So we'll get to see Vincent, Benjamin, and other colleagues from Ciel Terre also there. And another colleague from you both, another Vincent, will also be on stage sharing more insights about floating PV design. So if you all want to come, it will be very, very insightful discussions over there as well. And of course, we are sharing with you the code here in the screen so that you can register for our event in Amsterdam on 20th of September. So thank you very much, Vincent and Benjamin, and thank you all for the audience as well for tuning in with us today. And I wish you all a very lovely day ahead. Thank you.
Thank you, Manuela. Thank you, everyone.
Thank you.
Thank
Bye
you.
bye.
Goodbye.
See you in Amsterdam.
Bye bye.
See you.